Hi guys, this is Ms. Gruman here, and this is video 2 of 2 for the SuperTaster Lab and how to utilize Excel in order to make your graphs. So in the previous video, we utilized this data right here in order to make our first graph to determine if the average fungiform papillae density is associated with genotype. So go ahead and look at the other video if that's why you're here for that resource. So what we're going to look at is that we're going to look at the rest of our data to determine is Apopka High School's SuperTaster allele evolving. So we're going to be filling out these 3 data tables. Notate you are not going to make a graph utilizing this one. This one is just in order to assist us in getting all the information together. So you guys can go ahead and stop and I'll fill this out so you guys can see where I got this information from. So if we look at this, this would be like, this information is what you guys would pull off of the directions. So remember, you guys have data from 2010 and 2015. I'm working with 1995 to 2005. So what I'm going to do is that we're going to utilize this because this information will give us actually 2005's data, similar to how you guys had to figure this out to get 2020's data. So I'm just going to match up what numbers match up with these phenotypes. So homozygous dominant would match up to SuperTaster. So I'm just going to type these corresponding numbers in. And the reason I'm doing this is just to keep things organized so I can fill out the other 2 data table, and now everything is just in the same place. All 3 years information is in the same place. So this adds up to 66, which that is our sample size that we're utilizing right here. So that's perfect. Again, how you get Excel to do that for you is that you type in equals sum. Double click on sum when that pops up, and then drag the cells that you want to have added together. So that's how I get the value 66. So I'm just going to bold this. You guys don't have to bold this. I'm just doing this now. You guys know what I'm referring to. So if we're doing this, this is 50 individuals or 100 alleles. This is 130 individuals or 260 alleles. This is 66 individuals or that is 132 alleles. So we are going to have our 2 charts, our genotype chart, which that we will make a graph once we fill this out, and then we will make a secondary graph for alleles as well. So these are the 2 other graphs that we're going to fill out. Again, I'm just going to bold this, so now you can see that these are 2 data tables. And once you guys fill this out, you'll fill out the corresponding ones on your guys' lab report. So remember, P times P is equivalent to P squared. And so if we're looking at phenotype, that should be associated with your SuperTaster. So how we would calculate that is that we would type in equals. There's 15 out of 50 people. And then that would give us that. If you wanted to do this in terms of alleles, well, there is 30 alleles here for the 15 people out of 100. So you could type in the same thing. And so then you would go 30 divided by 100, and you would get the same value. So it doesn't matter if you do these in terms of alleles or individuals because the proportions will be the same. So 2PQ is associated with medium taster, so I'm going to go into equals 22 divided by 50, and then I'm going to do that for Q squared as well. So I'm going to go equals 13 divided by 50. And so then to check if I did this right, I can use the sum in Excel. So I'll type in sum, double click, and then I will go ahead and select all of these and the parentheses, and it should equal 1, which it does. So that means I didn't make a miscalculation. So I went ahead and did 2000 just to save time. So I'll go ahead and do 2005 if you need to see it one more time. So you would do equals, and then you would see that there's 39 out of 66. So I do 39 divided by 66, enter. And then I would go ahead and do for the rest of them. So equals 21 divided by 66. And then I would do equals 6 divided by 66 to equal that. So now I can check my work. I'm going to put equals sum, double click on sum, and add these all up. And if they equal 1, then we didn't miscalculate. So we didn't miscalculate. So that's perfect. So now what we can do we can go ahead and insert our graph corresponding to this. So I'm going to select the actual data that I'm going to utilize. Sorry guys about that. I just had to stop to kick my cats out of my room. So we're going to go ahead and now insert our graph. So I'm going to select everything associated to what I want to graph. Mind you, I am intentionally missing out the years, but I'll go ahead and manually insert that later. So I will go to insert, and then I will go to line graph. The reason I'm using a line graph is because we're utilizing the change in genotype frequencies over time. If we look at this, if you don't like this here, you can go to format legend right here, and then you can put it on the right side if you like. And then from there, you can see that it's on the right. If you like it on the bottom, that's fine too. It really doesn't matter where you put it, but I know most of you guys are used to it being off to the side right here. So my issue right now is that this says 1, 2, and 3 instead of the years. So how I'm going to fix that is that you can just select anywhere in the graph, or you can select this, and you would go to select data. So when you see this, it'll say the horizontal categories 1, 2, and 3. Well, that's not what we want to use. We want 1995, 2000, and 2005. So I'm going to go ahead and hit edit, and then I'm going to drag these 3 values, and I'm going to hit OK. So now you can see that it changed this. To confirm that you want this changed, you can hit OK. So you can keep these as genotypes. If you don't like that it says P or 2PQ, you can change this to homozygous dominant, if I can spell, capitalize. You can change this to, and see that it automatically changes for you. So you can do heterozygous, and then homozygous recessive. Either way, I would accept either, so it just kind of depends. What do you prefer to read? What do you visually like? So for the most part, your chart is done. Things that you're missing is that you need to actually change your chart title, and then you also need to add your other chart title. So you need your title axis. So if you click on this, this would include the y-axis title, and this would be the x-axis title, so you can click on that and edit it. If you wanted to see more options, you can see that both of these are checked off. So from there, this would be this. You guys just need to finalize editing in this. And so now we have the last chart, which is the allele frequency chart. So how we would utilize that is that we would need to calculate P and Q. So some people are going to want to approach to take like 0.3 and square root it to get P. Technically, that is one way to do it, but you're going to lowball the amount of the number because that's going to give you more of an estimate instead of an accurate number. The reason for that is because there's P alleles in this heterozygous right here. So if we scroll back up here, this is how we should determine how many P alleles there are. So if we look at this, our sample size is 50 individuals. So that would equate to 100 alleles. So now out of the 100 alleles, we need to determine how many of those alleles are the P allele. So we look at SuperTaster. Remember, SuperTaster is homozygous dominant, so that's equivalent to P squared. So if we look at it, if this is 15 individuals, right, that means that there's 30 alleles there. And out of the 30 alleles, all 30 are going to be P alleles. We can look then at medium tasters, which is 22 people, which is equivalent to 44 alleles. Out of those 44 alleles, however, because medium tasters heterozygous, only half of the 44 are going to be the P allele. So that means that would be 22. So, and then if I go to the non-tasters, which is homozygous recessive, 0 of those alleles would be a P alleles because non-taster is equated to Q squared. So when I solve for this, what I'm going to type in, I can go equals, and then I can scroll up. So I have 30 alleles here for P and 22 alleles here. So I can go 30 plus 22 and the parentheses, and then divide that by the total alleles, which would be 50 times 2, which is 100 alleles. So when I add that up, that will give me my p-value, and so then I can do the same thing with Q. So then when I do this, I can go to that there's 0 Q alleles from the super tasters. There'll be 22 alleles from Q alleles from the medium tasters, and then there will be 26 from the non-tasters. So I'm going to go parentheses 22 plus, let me scroll back up, plus 26 divided by 100 alleles. And so then that, oops, I did something wrong. So then I can go 22. Oh, okay. So I can see what I did here. If I look at this, this is saying 22 plus 26, and I was too inclusive on the parentheses. So let me go ahead and redo this. So I'm going to say equals parentheses 22 plus 26, and the parentheses, divided by 100. So that would be 0.48. So then I would go equals sum to see if I did this correctly, and I double click. And then if I select all of these and end the parentheses, this should equal 1, and it does. So that means I calculated that correctly. So then I can go ahead and do the same thing for 2000. So if I go to equals, and so then here I would say 14, so that would be 28 plus 68 divided by 260. So I'm going to do parentheses 28 plus 68 divided by 260. Again, I'm making the same error that I did last time. Divided by 260. And that will give me that value. And then I'm going to do it one more time here. So that will equal parentheses 68 plus 48 divided by 130. So then if I equal sum, so I did something wrong, so I need to go back and check this out. So this should be 68. Oh, this shouldn't be 48. I need to double this. So 48 times 2 would be 80. This would be 96. So I need to go back and do, and this is why we do the sum feature to see if we done good. So it should be 68 plus 96. Oops, I did something wrong. So 48 times 2, so that's 80, plus 16, that's 96, and then this should be 68, divided by 260, which I did not do here. So if you see this, we can see that this says 130, and it should say 260. And so now it equals 1. So again, that's why we do the sum feature, so now we can check ourselves. So once you fill out this whole entire chart, you're going to do the same exact approach to make a line graph to show the change in allele frequency over time. Thank you for your time, and I hope you guys found this helpful.